The same principle of electromagnetism that allows us to translate sound vibrations into an electrical signal or an electrical signal into sound vibrations, what we demonstrated by turning a speaker into a mic and a mic into a speaker. Well, this principle we can also use to make our first standalone circuit capable of making irritating sounds all by itself. For this purpose, we're going to take a speaker and a 9-volt battery and 2 clip leads. First, you connect the clips to the terminals of the speaker, like that. Then you connect one of these clips to one terminal of the battery, and then touch the other. And you'll notice that the speaker jumps up and down. So what we've done is we've made ourselves a rather odd little form of electrically assisted drum. It has some charm, but is not really much to get excited about. However, we can go on. Take the clip and now attach it, instead of to the battery terminal, to some rough piece of metal, like a file. You take a paper clip, open it up, and clip it now to the other terminal of the battery, so that now when we touch like this, we make a contact. But now what we can do is not just touch directly, but scrape and what we're doing is we're essentially hearing the surface of the metal, the irregularities of the metal. A little bit like scratching a record surface. You can do it with any piece of metal that has some textural variety to it, a little bit of corroded copper. Get very nice sparks sometimes too. All right, so a primitive record player of sorts. Then if you get 2 beer tabs and you put them in the ends like this, and you rest them in the speaker, the speaker, as it jumps, makes and breaks the connections. This is our first oscillator, what John Bowers calls the Victorian oscillator. By adjusting the tension and position of the clips, you can vary the pitch and even the tonal quality. Now, if we take 2 little bent bits of copper wire, we can program our first analog algorithm, just like computer music, only with more verdigris. The speaker, as David Tudor used to say, is not just a hole for sound to come through. And here we have a classic example of a Tudor-esque speaker instrument. The sound basically originates at the speaker rather than ending in it. By using the mutes, we can physically alter the sound even further, just as if this were, say, a trumpet. Now, obviously, or maybe not so obviously, the sound depends on the size and nature of the speaker. So if we put a little tiny speaker in here, we're going to end up with a very different type of sound. It will be, well, it'll be like this. And if we get a much larger speaker, things get much more interesting. Now we can turn the speaker into a percussion instrument by adding all sorts of stuff.